Okay, well, we have a fairly involved problem that involves a lot of the skills that you build in pre-calculus. We have this graph with 2 points on it. X is going to be the selling price. Y is going to be the demand, that is how many people want. We know if we sell it for whatever price corresponds to this point, we're going to sell the number that corresponds to the Y coordinate. So, for example, this point and this point gives us a price and a demand. It looks like the price is going to be between 1, 2, maybe it's 2, and it's dollars, say maybe $2, or maybe it's in hundreds of dollars, maybe it's $200. We don't care about that right now. We'll just go with the scale that we have. But that means we're going to sell, well, if this is 16, that looks like maybe about 12. Okay, so if the price is 2, we sell 12. Okay. Now, if we have this price, what's that price? Well, if this is 8, that might be somewhere close to 6. And what's our demand? Well, that's 16, 8 would be about here, 4 would be about here. Looks like the demand might be about 6. Okay, maybe. So the question was, estimate the coordinates of the 2 indicated points. So make your own estimate. I threw out a couple of numbers there, but don't take my estimates. Figure out your own. Estimate the coordinates of the 2 indicated points. Find the equation of the line through the points. Should say find the equation of the line to find the points. Then, in terms of the equation of the line, find the revenue function. What's the revenue function? That's how much money you take in. Then, for what X value does the revenue peak? And so forth. You can read the rest of the questions. Okay, so if you haven't worked it, if you have some problems understanding the situation, there's an explanation. Of course, if you have reviewed the preceding class, you've seen this whole process. But we're trying to see if you can follow the process now. So go ahead and work this thing, and then we'll pick up and go over it. Okay, now hopefully you've worked the problem at least as far as you can. So we've got these 2 points. There's going to be a line between these points. So I might as well go ahead and draw the line. Okay. Now we want to get the coordinates of the 2 points, because knowing the coordinates of the 2 points, you can find the equation of the line. We have x equals 8, and I chose 8 because it's easy to subdivide that. So I'll put a little bit of scale on this. I'll go halfway between 0 and 8, which would be about here. That's okay. That's about where x equals 4. Then halfway between 4 and 8, that would be about here. This would be x equals 6. I don't think that's a really great. Let's see. And here. Okay, I'll label it down here. X equals 2. So now we can make estimates of the coordinates of these points. So if this is 2, of course, 1 would be about here. It looks like x is about 1.5. Okay, so we can say this line here is 4, x equals 1.5, that's fine. Okay, we could subdivide the y coordinates, subdivide here, if we come out with about half one here, gives us y equals 8. Divide 16.5 plus we get 8. Divide 8.5 and we get 4. And well, I'll tell you, it looks like 4 is really close to this other line. And then if we want to divide the interval between 8 and 16, halfway from 8 to 16 is 12, that would be about maybe here. Now we've got an indication of a scale. We can estimate coordinates of the points. This would be x equals 1.5. It looks like maybe this line here is a little below y equals 12. I'll say y equals 11.5. This point, you know, I'm just going to say this point here is also pretty much y equals 12. I can't really tell this is halfway between here. Maybe it's a little more. It might go 4.3, but let's not mess with the decimals in a demonstration process. Now, this illustrates what you would do in a business if you knew, well, we set the price at $1.50 and we sold 11.5. So maybe that's 11.5 thousand or something like that. Okay. So this could be the demand of the audience. Let's go with 11.5 right now. Okay. And then if we set the price at, I didn't estimate this coordinate. Okay. Now here would be x equals 6. So the coordinate at this point would be maybe, I'll say x equals 5.5. Okay, so again, we set the price at 5.5, we sell 4 of them. Well, you know, what happens? So set the price at 1.5 and you sell 11.5. How much money do you get by selling 11.5 at 1.5 per unit? If it's 11.5, if the number is actually 11.5 and you're charging $1.50, you can figure that out pretty easily. 2 times 11.5 is 23, and half 11.5 is 5.75. It's 28.75. So if this price point tells you that you're going to take in about $29, 28.75, $29. I did that correctly. Now, if we set the price at 5.5, we sell 4 of them. Well, 4 times 5.5 is 22. So here we set the price maybe a little too high. We don't get as much revenue as we did. We set the price here. So if we want to maximize revenue, we're probably going to use the price between this one and this one. There's probably a sweet spot in between this price and this price. So what we do is we assume that the demand changes linearly with the price. So we have a straight line graph of demand versus price. It looks like I didn't show all my scaling over here. Should be able to see it, should understand what's going on there. Okay, and you should be able to make your own estimates using similar techniques. This corresponds to like market research. Okay. I think that, yeah, I've never done market research, but I think that would be in the province of market research. You're trying to determine what the demand is going to be as a function of price. Now, this is an overly simple model. Usually your demand is going to have, you know, your demand versus price function is going to look maybe something like this. I'm just guessing. Not necessarily going to be a straight line function. But we can do a simple model with a straight line function. to understand a lot about some of the decisions that could be made in a business. Okay. Also, the concepts and ideas that we use in analyzing this apply to all kinds of things. Okay, they apply to business, apply to all kinds of sciences, engineering, social research, political science, all kinds of things. Okay. So the task is going to be to find the equation of this line, which will give us an idea of what our demand is going to be if we plug in a price. So how do we do that? Okay, well, let's move over here. One way to find the demand function is to say, well, it's going to be a y equals mx plus b. Perfectly fine way to do it. Now, how do we do that? Well, we go back over to our graph now. And we can find the slope. Because that's slope-intercept form, we need m. Okay, so we construct fundamental triangle. At least if you're in my class, you better be able to construct a fundamental triangle. And we get the rise and the run. So the rise is where we end up at y equals 4, minus where we started at y equals 11.5. That becomes negative 7.5. Now, we draw arrows to make sure that everything has the right sign. And if you left off the arrows when you were working this problem, well, go back and review how we construct fundamental triangles. But I'm doing it here, so you might not need to review since you're seeing it here. But it's something you really want to know. You really want to be able to do this. I guarantee you, you're going to have to do at least one fundamental triangle and maybe more than one on the exam. Okay, so negative 7.5 is the rise and run is 5.5 minus 1.5. This is at x equals 5.5. Here's x equals 1.5. And that's 4. So the slope is rise over run. That's going to be, I'm going to put that in a box here next to the hypotenuse. Better outside the triangle than inside the triangle, but it doesn't officially have to be that way. As long as it's in your picture, so you don't have to look at a page of often disorganized, because you never know where you're going to go on a difficult problem. Disorganized work, you're not sure where to look to find your slope. But put it right there. It's going to be rise divided by run, and that would be negative 7.5 over 4. Okay. Well, negative 7.5 over 4 is 1.875. So I'm going to say it's about 1.9. Well, no, I'll say negative 1.88. Probably about 1.875. And I believe I did my arithmetic right there. If you get something different, double check it and let me know that I screwed up. Okay. Now, I want to document that calculation. So I'm going to say slope equals rise over run. Uh-oh, and I got it backwards, which is 4 over negative 7.5, which is approximately equal to 5. Something like that, okay? Okay, so look at what I did, and I really did that. I just looked at my numbers. Trying to do something with the numbers before I make sure that I was using the right numbers. So yeah, we're gonna correct that. Look what else I did. I didn't write the negative sign on it. And this is another reason you want to document all your calculations. If you make a mistake like I just made, wasn't thinking, okay, then you're going to catch it. Then you say, whoa, that's not what I got. I got this. Now, which one is right? Well, since I wrote this out carefully, and I screwed it up, I wrote it wrong. This was right in the first place. Okay, it's rise over run. And that's negative 7.5 over 4, which is negative 1.875. I think didn't have room to write 875 in here. 88 is going to be close enough because we don't expect a huge amount of precision out of this model. This model is going to give us a decent estimate of what we want to know, which is what price to charge to maximize our profit. All right, so sorry for the little glitch there, but at least I remember to put my negative sign there. That's really important. Negative signs are a huge source of error, and at least one person in the class here did a wonderful job on this thing. But let's put a negative sign there. Okay. And I'm not sure I saw on that graph, I didn't have time to look at that one. But if you have those arrows, if you don't have those arrows, okay, you're going to drive the business into the ground. You're going to be destitute. You're going to go bankrupt. Okay, don't let that happen. Get the math right. Okay, so anyhow, now we have it in there. Well, we don't have it today. We have the slope. Now, FT capitalized always means fundamental triangle. Okay. It's so close to negative 1.9. Why deal with all those significant figures that aren't all that significant? In this case, we'd probably be safe rounding that a little more to the negative 1.9. Okay. So y equals negative 1.9x plus b. How to find b? Well, how to find b is we take the coordinates of one of our points. So you've got an x and a y coordinate. We plug in for x, plug in for y. Now we'll have numbers for x and y. We'll solve for b. Plug in the coordinates. Now, which point has the nicest coordinates? I think 2, 1.5. We do that and we solve for b. So we get 1.5, that's the y coordinate. The x coordinate is 2 plus b. Well, we all know how to solve a linear equation. Let me demonstrate that maybe I can solve it. Okay, that's going to give us negative 3.8. We add that to 1.5 and we get 5.3. Which is ridiculous. Something's wrong there. I got my numbers wrong. I looked at the x equals 2 here. I didn't look at the x equals 1.5. So again, realize and be careful about that. Okay. Always be checking yourself all the way through. I got something that I knew couldn't be right. I'll explain to you in a minute how I knew it couldn't be right because of what I was looking at on the graph. Okay. So the point is 1.52. So now we get 2 equals negative 1.9 times 1.5. He's not looking at my graph carefully enough. The x coordinate of this is 11.5. And the y coordinate is 11.5. Yeah, but I take this out again. So we get 11.5 equals negative 1.9 times 1.5 plus b. We solve this and we get b equals what? Okay, well, half of 1.9 is 0.95. So negative 1.9 and half of negative 1.9 is negative 2.85. We add that to 11.5 and we get 14.35. And finally, we get something that makes a little bit of sense. Now, why does this make sense? Well, what do we do next? We plug that into this equation. And I'll round off 14.4 since you've already done it for a amount of rounding off. Now there is our demand function. Y is the demand. X is price that we set. Okay. Very good. Now, how much money do we take in? We want to find the revenue. You get the revenue, multiply price. The number sold. We already did that when we just looked at these points and said, okay, if I sell 11 and a half of them at $1.50, I'm going to make $28.75. I'm going to take in $28.75. That won't be my profit. That's how much money I'll take in. Okay. If it's costing me $10 to run my business, then my profit would only be $10 less. 18, about $19. Okay. You want to understand that because we're going to need that in a minute. Okay. And here, if I sell it for $5.50, I sell 4 of them, I'd only take in $22, so my profit's down to $12. Okay. Now, somewhere in between here again, we're going to hit the sweet spot. We're going to find that using just a little bit of recalculus and graphing. Okay, so what do we multiply the price by the number sold. What's the price? Well, the price is X and the number is Y. So the revenue equals X times Y. Of course, Y is a function of X, and that's what we want to use for Y. So that equals X times negative 1.9 X plus 14.4. That's the negative 1.9 X squared plus 14.4. 14.4x. Standard law, I've got to multiply both this by x, obviously. Okay. There's a revenue function. Now, what's our maximum revenue? Well, we graph this thing. And we don't graph it by evaluating it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For the points on the graph, that's how you do it in early algebra 2 and algebra 1. We use transformations. Okay. Or we use some other method. Now, it's pretty easy to factor this. We've already got it factored. So we can see where the revenue is 0, if x equals 0, or if this factor equals 0. So we can easily find the zeros without using the quadratic formula, but let's go ahead and use the quadratic formula just to demonstrate it, because in most cases, the real world is not, well, in this case, you don't really need it. Actually, since we're going to use the quadratic formula on the profit function, I'm going to go ahead and use what we got. Okay. I'm using quadratic formula on this. Okay. So again, okay. R versus X. What are the zeros? Zeros occur when R equals 0. Set this expression equal to 0. We could easily also set this expression equal to 0, but if we did, we'd probably say, well, I can factor out an X, and we can do that to this. Okay, well, this leaves X equals 0 or negative 1.9x plus 14.4 equals 0. Well, we can start sketching our graph. Here's revenue. Here's X. We know that X equals 0, R equals 0. Which is a point on our graph that happens to be the origin. It also happens to be the y coordinate. Now, normally, when we graph a quadratic function, we find the y-intercept, but in finding the zeros, it turns out that the y-intercept is at exactly the same point as one of the zeros in the function. The other zero, well, we're going to divide 14.4 by 1.9. Divide 14.4 by 2, you get 7.2. And 5% more than that gives us like 7.5. Okay, 0.75. 7.5. Okay, so we're going to have a 0 here. The next about 7.5. All right. Now we want to find the maximum value. We know that the graph, because of the negative in front of 1.9x squared, that the graph is going to have, well, This graph is going to be a transformed x squared graph. The transformation, first thing you're going to do is you're going to multiply x squared by negative 1.9. That's a vertical stretch and a reflection. So the graph is going to go from this to this. So the graph has got to be an upside down parabola because that negative, because think about the transformations you'd have to do to get here. That's what you need. Okay, so graph's going to look something like that. Now, where is the maximum profit? Or, I'm sorry, the maximum revenue. Well, the revenue is this coordinate. Maximum revenue is going to occur here. Occurs here. Okay. How are you going to find the maximum revenue? Well, if you knew the X value for the maximum revenue, you could plug it in here and find the value of R. We know the X coordinate for the maximum revenue. Well, yeah, we do. I mean, we don't know it yet, but because of symmetry, here is the vertex, it's the high point. Here's the axis. Of symmetry. What's the axis of symmetry here? What's the x coordinate? Because of symmetry, this line has to cut this graph exactly in half with identical halves except for the reflection. Okay. Now, so chop this half off, flip it over this way, and slap it on here. It's going to be identical to what we've already got. Well, that means that this point has to be exactly halfway between these 2 points. It's halfway between the zeros. So it's half. X equals 0 plus 7.5 over 2 equals 3.75. No, 3.25, I'm sorry. Okay. So the axis of symmetry is X equals 3.25. Okay. Coordinates of the vertex are X and R of X. This is a graph of R of X. Give you an X coordinate, then R of X is a Y coordinate. That is 3.75, R of 3.75. That's approximately, I'm not going to get that exact, because those numbers are just not that bad. I could probably do it. Oh man, what's 3.75 squared? 4 minus, well, let's say it's ballpark 14, 4.9 times that is almost 2 times that would be negative 28, maybe around negative 28. And then yeah, something pretty close to 28, and that's a little bit low because we already get more than 28 from this point here. Let me stop a minute and just look through these numbers. I'm not seeing it I'm gonna pretend that's about 30. I think it's a little less than that. So it's likely that there's some kind of an error in some of my calculations. Some of my numbers might be a little bit off. I don't see anything right off the top of my head. Not sure how to do half. There it is. Okay. So that would tell me this occurs at y equals about 30. Question mark on that. We work it out. Okay. Let's illustrate the rest of the process. And again, be good for you just for practice to work through this, work through the numbers, see where I might have gone wrong with the numbers. And again, the problem I'm seeing is that if x equals 2, that puts us about here. And I know when x equals 2, the revenue, or when x equals 1.5, even the revenue is like close to 30. So something's wrong somewhere. So let's just proceed. And before we go on, let me make one more comment. This is 2, this is 4, 3.75 would be about here. On the graph, that means we'd sell about 8, and 3.75 times 8, yeah, okay. I know what it is. When I got the 28 here, I was multiplying by 2.5, not 1.5. So multiply that by 1.5 to get something a lot less, and that reconciles what I was looking at. Now you understand, I'm looking at all aspects of this problem to make sure they're all consistent. So right there, I thought I'd made a mistake, but I couldn't see it in my calculations. And it turns out where I made the mistake was in this additional estimate of what your revenue would be if you had x equals 1.5. And I carelessly, instead of multiplying by 1.5, multiplied this number by 2.5. Okay, so that was the source of my uncertainty. You want to be thinking about things like that. And of course, you want to be sure that you're doing your steps right as well. Okay. The idea is always be skeptical of what you're doing. Always make sure it's consistent with what common sense tells you. So that 30 should probably be closer to 28 or so. There's more I could say. And one more thing I will say is y equals mx plus b is not the only way to find the equation of this line. Okay. You could draw a straight line through these points. If you have the graph. And estimate the x-intercept and the y-intercept. We could even kind of check our equation and see if the x-intercept and y-intercept are about what we'd estimate. Looks like x ought to be close to 9, the x-intercept, and y ought to be close to, if that's 14, that's 16. That's around 14, a little over 14. Well, looking at the graph, I said the y-intercept should be a little over 14. And look what I got for the y-intercept. I got 14.35. And I wasn't remembering that 14.35. I was looking at the graph, not being prejudiced by the number that I calculated. It was in the back of my mind, but I didn't really, so subconsciously, there might have been some bias when I made that estimate. And the x-intercept would be around 9. Well, if we take this equation and set y equal to 0, and we don't get 9. Okay. We get something closer to like 8. Not even 8. Yeah, close to 8, a little over 8. Well, it is a little over 8 on the graph. Yes, intercept a little over 8, but this is a hand-drawn graph with a hand-sketched set of scaling numbers, okay? So you expect a little discrepancy. If you do this rigorously with machinery, you get a better result, a more accurate result. But human behavior being what it is, this model is not going to be 100% accurate. So this model is probably as close to the actual behavior of the market as the model you could get. You did all the calculations based on those two things to a bunch of significant figures. Okay, well, now we want the revenue function. Sorry, we got the revenue function. We want the profit function. It's not hard to understand that your profit is the revenue minus the cost it takes you, the cost minus what it costs you to produce and sell these things, or to buy them. Maybe you buy them at wholesale and mark them up, okay? Many ways that can be done, and somebody in business probably knows a bunch of ways that I would. Okay. Anyhow, profit is revenue minus cost. Revenue function first of all, there's your revenue function. I'll label that RS. Minus the cost function. Here's your cost function. 2 plus 3x. And what it costs you, the more items you sell, well, the more it's going to cost you if you're buying these items wholesale, right? Maybe you're buying these items for $3 a piece and you're selling them for whatever, okay? And maybe it costs you $2 to set up your production or to run your shop or to, well, whatever. Those are your costs. Now, I'm going to change that function. I'm going to say the cost is 20 plus 3x. It worked out for 2, that's fine. But I'll do this. Now, if I work all this out, I still have the negative 1.9 x squared, but now I've only got 11.4 x, and then I've got minus 20. So profit is this. Now, graph. The profit function. You start with the quadratic formula. Steps. Put your zeros. Set this equal to 0. And you're going to get x equals negative 11.4 plus or minus the square root of 11.4 squared minus 4 times 20, which is 80, times 1.9, which is way too much. When I set this equal to -20, I killed your business. Okay? When I set this number to 20 instead of 2, I just destroyed your full business. Okay? So I'm going to change it. Yeah. If it's 20, then this is your function. Now, as a matter of fact, I'm going to just change it back to what our original was. Those people that worked at the original 2. Now, what I was going to get was I was going to get a negative under the radical there. Okay? Which means there's no real solution, which means your graph stays below the x-axis, which means that you never make a positive profit, you're going to lose. Now we could do that, we could figure out your loss, but I'm going to stop mucking around with the equation. We've only got a couple of minutes left, that's pretty easy to finish up. Okay, so let's go with -2 here. And now, before AC is just 8 times 1.9, which is like approximately 15. And like this approximately over 2 times -1.9. Well, right there, we have almost everything we need in order to start the graph. First of all, we have the axis of symmetry, which is right here. That's the -b over 2a. Okay. And that's 11.4. That's a little less than 4. So that's going to be about 3. A little more, a little less. Okay. Not going to spend much time thinking about it since I'm almost out of time. Okay, this 11.4 squared is about 130. Okay, minus 15 is 115. So this is approximately 3 plus or minus square root of 115 is a little less than 11, say 10.7 divided by up to 3 plus or minus 2, which means x can be 5 or 1. Well, if x is 3 here, then let's say x equals 5 here, x equals 1 here. Those are your zeros. The graph is going to look like this. One thing that we do know about this graph is our y-intercept is going to be at -2. Now, can't review everything about graphing quadratic functions. The y-intercept occurs when x equals 0. You put 0 in for x, you're going to get -2. There's y-intercept. And now we sketch our graph. There's our peak. Now it looks to me like our peak is around 4 or 5. This is the hand sketch graph. I'm guessing 4 or 5 to the graph, but how do I calculate it? I put x equals 3 into the function. I'm gonna say y equals p of 3. That means put 3 into your profit function, because 3 is your projected demand. Okay, so you put 3 in here. 11.4 times 3 is roughly 34. 3 squared is 9. 9 times negative 1.9 is about 17. So that leaves you 18, 16. I'm getting 16, so my graph isn't all that accurate. It's about 16. So this says the price is about 3, the property is maximized. Half P of 3 roughly equal to 16. Now, you can work that out, the whole model. The reason I choose this model right as we're starting to review is that it illustrates how you find a straight line. Okay. And it illustrates how you draw a quadratic, and it illustrates that this can mean something. Okay. You also have models in your open math assignments where you calculate trajectory. Trash can's over there, it's not my shoulder, calculate the trajectory. And oh, it came up short. I was like, okay. Obviously, I made another mental error when I calculated the trajectory. Now, the point is, now that trajectory is a quadratic function. It's a quadratic function of our position. The height is a quadratic function of time. And you have many examples in your text of that sort of thing. You want to understand those examples and what they're telling you. Okay, those would be two primary problems for interpretation.